An embankment dam is a massive artificial barrier constructed from compacted natural materials, like soil, sand, gravel, or rock. Rather than using concrete and cement binders, these structures rely on the immense weight and friction of their particles to withstand the pressure of the water they impound. How they work. Embankment dams are engineered with specific zones to ensure stability and watertightness. Impervious core. A dense inner core, usually made of clay, prevents water from seeping through the structure. Supporting shoulders, layers of coarser rock or earth on either side of the core, provide the necessary structural weight and support. Gravity dam. Engineers must carefully design gravity dams to balance several competing forces. Water pressure, the horizontal, several competing forces. Water pressure, the horizontal thrust of the water pusher. Dam pressure, the horizontal thrust of the water pushes the dam downstream. Uplift pressure, water seeping underneath the dam creates upward pressure, reducing the effective weight. Sediment ice, silt accumulation and expanding ice can add to the horizontal forces. Gravity, the self-weight of the concrete masonry acts downward to counter these pushing and sliding forces. Common failure modes. To prevent collapse, gravity dams are designed to resist overturning, the water pressure pushing the dam over its downstream toe. Sliding, the horizontal water force pushing the dam across its foundation. Crushing, structural failure when compressive stresses exceed the strength of the concrete. When compressive stresses exceed the strength of the concrete. A rock-fill dam is a massive embankment dam, primarily constructed using compacted rock fragments, boulders, and gravel. It relies on its weight and the interlocking strength of the rocks to resist water pressure, and it incorporates a watertight core or membrane to prevent seepage. Core structure and materials. Rock-fill dams are carefully engineered using distinct zones, each serving a specific structural or functional purpose. The shell rock fill. The bulk of the dam consists of blasted or naturally occurring rock fragments. This provides immense shear strength and flexibility, making the dam highly resistant to earthquakes. Impervious core membrane. Because rocks are highly permeable, a waterproof barrier is required to hold back the water. This is typically a clay core placed inside the embankment, earth core rock-fill dam, or a layer of asphalt or reinforced concrete placed on the upstream face, concrete-faced rock-fill dam, where reinforced concrete placed on the upstream face, concrete-faced rock-fill dam. A diversion dam is a structure built across a river to raise the water level and redirect a portion or all of the flow into an artificial canal or waterway. Unlike traditional storage dams, they do not create large reservoirs. Key features and functions. Water redirection, diverts water into systems for irrigation, municipal water supply, or industrial use. Hydropower generation, can redirect water into penstocks or canals to feed hydroelectric generators. No large reservoirs, designed simply to alter a stream's natural flow and raise its level so gravity can pull the water into surrounding networks. Types of structures. They are often referred to as weirs or barrages, when they use a system of adjustable gates to control the volume of water passed down a river versus the amount diverted. Barrages, pass down a river versus the amount diverted. A steel dam is a specialized dam where the primary retaining structure is made of steel rather than traditional materials like masonry, earth, or concrete. Or concrete. It consists of an upstream steel skin plate supported by a framework of steel struts and buttresses that transfer the water's load to the foundation. Pros and cons. Pros: steel dams can often be fabricated and constructed much faster than massive concrete structures, and their steel components allow for precise calculations of load-bearing strength. Cons: they require higher initial material and fabrication costs, and they are highly susceptible to corrosion and temperature-related expansion-contraction if not properly maintained.